In this lesson, you will learn how to calculate the volume of pyramids and cones. The volume of a three-dimensional solid is the amount of space it occupies. Volume is going to be measured in cubic units. For example, cubic inches, cubic feet, cubic yards. Be sure to always include your units. A pyramid is a polyhedron formed by connecting a base and a point. Each base edge and the point of the pyramid will form a triangle, so be very careful. Every pyramid will not be called a triangular pyramid. The shape of the base will actually determine the name of the pyramid. So there are some examples of different types of pyramids. The volume of a pyramid will be 1/3 the area of a base B times the height. If you have previously worked with prisms, the volume of a prism is just the area of the base times the height. But the volume of a pyramid has that 1/3, so that's a difference there than prisms. Where, of course, the height again of the pyramid is the distance between the base and the point. Be very careful, it will not be the slant height. If you were asked to stand up tall to see what your height is, you would stand straight up and not slouch over to the side to find your height. So the general formula for volume of a pyramid will be 1/3 big B, which stands for the base area, times the height. So here are some examples of some pyramids, noticing that the slant height here is not the height you will use for the H. The height of the pyramid that goes from the point to the base figure, that is the height that we need for H. Again, here in this picture we see another slant height, and the height of the pyramid, that's the value that you'll need. But let's look real quick on why do we have the 1/3. If you notice 3 cones here, if we added the volume of those 3 cones together, it would equal 1 cylinder if the height of the cone equals the height of the cylinder and the base area, so in this case the circle, that area is the same as the area of the base figures in the cylinder. If the height is the same and the base area is the same, 3 cones, those volumes added together, will equal 1 cylinder. It works with any type of pyramids. So in this case, these are rectangular pyramids. 3 of those will add to equal 1 rectangular prism. So 3 pyramids of whatever base figure, they could be hexagons on the bases, they could be triangles on the bases, as long as the height of the pyramid matches the height of the prism, and also the base figure, the area of that base figure matches the area of the prism's base figure, then it will be 3 of these pyramids equaling 1 of the prism's volume. That base area, or when that base figure has the same area and as that cylinder or prism, then it's going to be 1/3 the volume of the cylinder or prism when they have that same height. So let's look at some examples. Oh, before we do that, let's look at the specific formulas. Just like with prisms, you will replace the big B depending on the base figure. So in this case, our figure here, if we lightly highlight or shade, it is a rectangle. Because that comes to a point, we will have 1/3 times that base area times height. So our base area is going to be length times width, since this is a rectangle, and we substitute that in for the big B. Don't forget your 1/3 for that pyramid, length times width, and then of course the height on the end for the volume. Again, for the next one here, we have a triangular pyramid. We see that triangle as the base, so that base area is 1/2 base times height, replacing, in our general formula, replacing the big B with 1/2 base times height. Again, remembering the 1/3, because this is a pyramid, it comes to a point, and of course having the height at the end for the volume. And then finally, for a circle, or cone, we have the circle base. So the area of a circle is pi r squared. Replacing that with that big B, because that's the base area, we have 1/3 pi r squared, again, our h at the end. So now let's look at some examples. Here we have our first example. We will identify the shape, we will write the formula, and then find the volume. So first of all, we see that shape is a cone. The formula for that cone, if we go with the general formula, it's 1/3 B times big B times H. 1/3 because it comes to a point, it is a cone. Big B stands for our base area, so we'll replace that with the area of this circle and then times our height. So let's write that specific formula for the cone. 1/3 pi r squared, that is replacing that big B, and then of course we have our H. So let's find our values. Our radius is given to us, that is a radius of 6. The height, however, is not given. Be careful, 10 is not the height. When you're standing up to find your height, you're going to stand up real nice and tall, and so this vertical distance is the height of the cone. But we can solve for that, so let's go over here to the side. Using Pythagorean theorem, we'll do 6 squared plus h squared equals 10 squared. Remembering 10 has to be the c value because it is the hypotenuse of that right triangle. So if we take h squared, subtracting that 6 squared from both sides, we'll say 10 squared minus 6 squared. In our calculator we get 64 for h squared. In order to find the height, we have to take the square root of both sides, and the square root of 64 is 8. So our height of this cone from that point to the base figure is going to be 8 feet. So let's substitute in those values. We get 1/3 pi, our radius was 6, so 6 squared times our height we solved for, which is 8. Let's calculate that, of course, using the pi button. So 1/3, you can do alpha y equals or just 1 divided by 3. So 1/3 pi r squared times the height, we get 301.59. That 2 will keep the 9 there, so 301.59, and we're in feet, making sure that you have cubic feet there. Example number 2. Here in this picture, the base is a triangle, so that means this picture is a triangular pyramid. The volume formula for this pyramid, the general one, is 1/3 big B H, but we need to know the specific formula so we can calculate this volume. So volume equals 1/3, the big B we replace with 1/2 base times height, because that's the area formula of a triangle, is 1/2 base times height. But then don't forget that last H. It's a common mistake for students to miss that H on the very end of our volume, so don't leave it off. So let's find our values. The first B and H is from just the triangle, so if you have to cover up the top part of your figure and just look at that base figure of that triangle to find the base and the height. So the base, if you notice along this line right here, is the 12. So that would make the height along this line here, that 9.2 as our height, because we're just wanting to look at that shaded triangle on the bottom, which is the base figure. So 12 is the base, height of 9.22. Well, then the last H will be the height of the entire picture. So looking at the entire picture from the point, the vertical line that goes to the base figure, that is a height of 13. So let's plug in those values. So our volume is going to be 1/3 times 1/2 base, which is 12, times height, which is 9.22, times the height of the entire figure, so 13. Calculate that. So we have 1/3 times 1/2 times 12 times 9.22 times 13. Let's check to make sure everything's entered in correctly, or you could always enter it in a second time. Here we find our volume to be 239.72. Of course, include your units. We're in cubic yards for volume. And for our last one here, not our last one, we have number 3 and then number 4. So our last figure here, this figure is a rectangle as the base. So that's going to make it a rectangular pyramid. Again, starting with the basic formula, 1/3 BH, where the big B is the base area. So we can replace that 1/3, replace the big B with length times width, because the area of a rectangle is length times width. And again, don't forget that last H. We need the 1/3 because it comes to a point. Length times width, because that's our base area, that's a rectangle, so length times width is how you find that area. And of course, remembering the H at the end. So let's find our values. The length of the rectangle is 14. The width of the rectangle is 8. And the height of the entire figure from that point vertically down to our base figure will be 11. So that volume is going to be 1/3 times 14 times 8 times 11. Using our length, width, and height, we have to multiply it by 1/3 because it was a pyramid. So let's calculate. 1/3 times 14 times 8 times 11. And it gave us a fraction, so let's do math, arrow down to decimal. We get 410.66, rounded in the nearest hundredths place. You look one decimal or one place behind, that's greater than 5, so it will make it round up. So 410.67, we're in centimeters, and it would be cubic centimeters for that volume. Now for our last example, number 4. We have a circular surface area of a cone has a radius that is equal to 3 times the height of the cone. We're asked to write a formula that can be used to find the height in terms of volume. So first notice we're talking about a circular surface area of a cone. So that specific formula for a cone is 1/3 pi r squared h. We're also told that the radius is equal to 3 times the height. So the radius is equal to 3 times h. They're wanting a formula that can be used to find h. So when we leave our final answer, it should just say h equals some sort of formula. And it does want it in terms of volume. So let's substitute in what we know. We know the radius is 3 times the height. So volume equals 1/3 pi r squared, and we're told that r is 3h times another h. So let's simplify, first starting with our exponents. So we have 3 squared is 9, h squared is h squared, and then I'll bring down that other h. Well, notice we can simplify here. H squared times h, this is h to the second, this is h to the first, that really gives us h to the third. While I do that, I'm going to rearrange these values, the 1/3 times the 9, so we can deal with that in our next step. So here I just rearranged the 9 to be beside the 1/3, so we can deal with that. Of course, I brought down my pi. H squared and h to the first We add those exponents to make it h to the third. So let's deal with this part, this 1/3 times 9. You could also think about that as 9 over 1. So 1 times 9 and 3 times 1. So it's really just 9 divided by 3. So that really simplifies to be 3 pi, and we have our h to the third. So it really started off as a big scary problem, and we've slowly just kind of simplified down, and it's looking a little bit better. Remember, our whole goal is to find an equation where it can be used to find h. So we need to solve for h. Well, notice what's over here with the h. We've got this 3 pi and we have this exponent. Well, we need to undo the 3 pi first. So let's do that by dividing. Dividing will undo the multiplication. Moving those to the other side, leaving just the h to the third by itself. So we have h to the third equals what's here on this other side, v over 3 pi. And so our last step is to undo this exponent of cubed. So we can undo that by taking the cube root. Just like whenever something is squared, you can undo that by taking the square root. Here we will undo it by taking the cube root. So taking the cube root of both sides, we'll get our h by itself because cube root and cubed cancel. So h is going to equal the cube root of v over 3 pi. So now, if you had a cone with a radius that's equal to 3 times the height, doesn't matter what that height is, we could find that volume, plug it in, and be able to very easily calculate the height now with this formula that's in terms of v.